According to the National Electrical Code, the NEC, a wet location is defined as a location where water is present in the form of rain, snow, sleet, hail, wind-blown droplets, or condensation. In this specific case of a mobile home, whether the under-chassis area meets this definition requires careful consideration. While the area is often shielded from direct exposure to moisture, exceptions can occur. To accurately assess whether the under-chassis area in your specific situation qualifies as a wet location, it's important to consider several factors. Firstly, evaluate the presence of moisture. Has the under-chassis area historically experienced moisture intrusion, such as from leaks or flooding incidents? Secondly, consider the adequacy of protection. Is the under-chassis area fully enclosed by a skirt or another type of covering, and does this covering effectively prevent water intrusion? Thirdly, consider the potential for physical damage. Are there any sharp edges, protruding objects, or other potential hazards present that could potentially damage the cable within the under-chassis area? Based on the information provided, it's plausible that the under-chassis area of your double-wide mobile trailer office may not actually be classified as a wet location, and therefore may not necessarily be subject to physical damage. However, it is crucial to thoroughly assess all of the previously mentioned factors to arrive at a definitive conclusion. If, upon careful assessment, the under-chassis area is determined to be a wet location or is deemed susceptible to physical damage, you may need to implement corrective actions to ensure compliance with electrical codes and safety standards. Firstly, you could use wet location rated cable. Install a cable that is specifically designed and rated for use in wet locations, such as UFB or use cable. These types of cable are manufactured with insulation and jacketing materials that are resistant to moisture and degradation in wet environments. Secondly, you could provide physical protection. Install the cable within a conduit or another protective enclosure to shield it from potential physical damage. Conduit provides a robust barrier against impacts, abrasion, and other forms of mechanical stress that could compromise the integrity of the cable. Thirdly, you could relocate the cable. If feasible, reroute the cable to an alternative location that is not subject to the same environmental hazards or risks of physical damage. This may involve moving the cable to an interior space, an elevated position, or an area with better protection from moisture and physical impacts. In conclusion, the ultimate determination of whether the under-chassis area in your particular situation qualifies as a wet location and necessitates special protection measures is best made by a qualified and licensed electrician. A qualified electrician possesses the expertise and experience to conduct a thorough physical inspection of the installation, taking into account all relevant factors and applicable codes and standards. Their assessment will provide you with the most accurate and reliable guidance and the appropriate course of action to ensure electrical safety and code compliance. Consider the type of wiring. NM cable, also known as non-metallic sheath cable, is commonly used for interior wiring in residential buildings. It consists of 2 or more insulated conductors enclosed in a non-metallic jacket. NN cable is designed for dry locations and is not suitable for use in wet or damp environments. UFB cable, or underground feeder and branch circuit cable, is a type of cable specifically designed for direct burial in the ground and for use in wet locations. It has a moisture-resistant jacket and is suitable for use in applications where it may be exposed to moisture or water. Use cable, or underground service entrance cable, is another type of cable designed for direct burial and use in wet locations. It is typically used for bringing power from the utility transformer to the service entrance of a building. Consider the National Electrical Code, the NEC. The NEC provides guidelines and requirements for electrical installations to ensure safety. It defines different types of locations, including dry locations, damp locations, and wet locations, and specifies the types of wiring methods suitable for each location. According to the NEC, a wet location is defined as an area subject to saturation with water or other liquids, such as areas exposed to weather, car washes, and some industrial facilities. NM cable is generally not permitted in wet locations, as it is not designed to withstand prolonged exposure to moisture. UFB and use cables are specifically designed for wet locations and direct burial. If an M cable is installed in a wet location, it can deteriorate over time, leading to electrical hazards such as short circuits, ground faults, and even fires. The moisture can damage the insulation, causing the conductors to come into contact with each other or with grounded surfaces. The inspector's concern about physical damage is also valid. An M cable is relatively fragile and can be easily damaged by impacts, abrasion, or punctures. In an under-chassis environment, the cable may be exposed to rocks, debris, or other objects that could cause damage. If the NM cable is damaged, it can create a safety hazard and may need to be replaced. The inspector's recommendation to use wet location rated cable or provide physical protection is in line with the NEC requirements. Using UFB or use cable would ensure that the wiring is suitable for the wet environment. Installing the cable and conduit would provide additional physical protection. If the under-chassis area is determined to be a wet location, the NM cable should be replaced with a suitable wet location rated cable, such as UFB or use. Alternatively, the NM cable can be installed in conduit to provide physical protection and prevent moisture from reaching the cable. If the NM cable is already damaged, it should be replaced immediately, regardless of whether the under-chassis area is considered a wet location. Damaged wiring poses a significant safety hazard. Be sure to use appropriate fittings and connectors that are rated for wet locations when installing the cable or conduit. This will help to prevent moisture from entering the electrical system. Consider consulting with a qualified electrician to determine the best course of action for your specific situation. They can assess the conditions in the under-chassis area and recommend the appropriate wiring methods and materials. In addition to the points above, let's consider grounding and bonding. Grounding and bonding are essential for electrical safety. They help to ensure that electrical faults are quickly cleared, reducing the risk of electric shock and fire. In a mobile home, the grounding system should be properly installed and maintained. This includes grounding the metal chassis and bonding all metal components to the grounding system. The grounding conductor should be sized appropriately for the electrical load. It should be connected to a grounding electrode, such as a ground rod or a grounding plate. Bonding is the process of connecting all metal components together to create a low impedance path for fault current. This helps to ensure that the fault current will flow quickly to ground, tripping the circuit breaker or fuse. All metal components, such as the chassis, metal water pipes, and metal gas pipes, should be bonded to the grounding system. The bonding conductor should be sized appropriately for the electrical load. They should be connected to the metal components using approved bonding connectors. Proper grounding and bonding can help to protect against electrical hazards in a mobile home. It is important to have the grounding system inspected regularly by a qualified electrician to ensure that it is functioning properly. Consider surge protection. Surge protection devices, SPDs, can help to protect electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD work by diverting the surge current away from the electronic equipment, protecting it from damage. SPD are available in a variety of types and sizes. They can be installed at the service entrance, at branch circuits, or at individual pieces of equipment. When selecting an SPD, it is important to choose one that is rated for the voltage and current of the electrical system. It is also important to choose an SPD that is designed for the type of equipment being protected. SPD can help to protect electronic equipment from damage caused by voltage surges. They are a relatively inexpensive way to protect valuable equipment. Consider GFCI protection. Ground fault circuit interrupters, GFCIs, are devices that protect against electrical shock. GFCIs work by monitoring the current flowing in a circuit. If the current flowing out of the circuit differs from the current flowing back into the circuit by a small amount, the GFCI will trip, cutting off the power to the circuit. This can prevent a person from being shocked if they come into contact with a live wire. GFCIs are required in certain locations such as bathrooms, kitchens, and outdoor areas. They are also recommended in other locations where there is a risk of electrical shock. GFCIs are available in a variety of types and sizes. They can be installed at the circuit breaker, at the receptacle, or as a portable device. GFCIs can help to protect against electrical shock. They are an important safety device that should be installed in all locations where there is a risk of electrical shock. Let's think about the type of mobile home construction. Mobile homes are typically constructed with a metal chassis or frame that supports the structure. The under chassis area is the space between the bottom of the floor joists and the ground. This area is often enclosed with skirting to improve aesthetics and provide some insulation. The skirting can be made of various materials, such as metal, vinyl, or wood. The effectiveness of the skirting in preventing moisture intrusion depends on the material, installation, and maintenance. If the skirting is not properly installed or if it becomes damaged, it can allow moisture to enter the under chassis area. The presence of moisture in the under chassis area can create a damp or wet environment. This can lead to several problems, including corrosion of metal components, mold and mildew growth, and damage to electrical wiring. The NEC requires that electrical wiring be installed in a safe and workmanlike manner. This includes protecting the wiring from physical damage and moisture. In wet or damp locations, the NEC requires the use of wiring methods that are suitable for those conditions. NM cable is not permitted in wet or damp locations. USB or use cable are suitable for these locations. When installing electrical wiring in the under chassis area of a mobile home, it is important to consider the potential for moisture and physical damage. The wiring should be protected from these hazards by using appropriate wiring methods and materials. If the under chassis area is determined to be a wet or damp location, the wiring should be replaced with a suitable wet location rated cable. Consider physical protection methods beyond conduit. While conduit provides excellent physical protection, other options may be suitable depending on the specific circumstances. Firstly, consider liquid-tight flexible metal conduit (LFMC). LFMC is a flexible conduit that is designed to be watertight. It is suitable for use in wet locations and can provide good physical protection for wiring. Secondly, consider electrical metallic tubing (EMT). EMT is a thin-walled metal conduit that is lighter and less expensive than rigid metal conduit. It provides good physical protection for wiring and is suitable for use in dry and damp locations. Thirdly, consider flexible metal conduit (FMC). FMC is a flexible metal conduit that is often used for short runs of wiring. It provides some physical protection for wiring, but it is not watertight. Fourthly, consider cable trays. Cable trays are open support systems that are used to support and route cables. They can be used to support a variety of cable types, including NM cable, USB cable, and use cable. Fifthly, consider cable ties and supports. Cable ties and supports can be used to secure cables to walls, ceilings, or other structures. They help to prevent the cables from sagging or becoming damaged. When choosing a physical protection method, it is important to consider the specific environment and the type of wiring being used. The protection method should be appropriate for the conditions and should provide adequate protection for the wiring. Consider the type of fault current path. A low impedance fault current path is essential for proper operation of overcurrent protection devices, such as circuit breakers and fuses. A low impedance path allows a large fault current to flow quickly, causing the overcurrent protection device to trip and interrupt the circuit. This helps to prevent damage to equipment and reduce the risk of electrical shock. The fault current path includes all of the conductors and connections in the circuit, from the source of power to the point of the fault. The impedance of the fault current path is determined by the resistance and reactance of these components. Resistance is the opposition to the flow of direct current, DC. Reactance is the opposition to the flow of alternating current, AC, caused by inductance and capacitance. A low impedance fault current path is achieved by using conductors that are sized appropriately for the electrical load and by making sure that all connections are clean and tight. Loose or corroded connections can significantly increase the impedance of the fault current path. Grounding and bonding also play a critical role in providing a low impedance fault current path. The grounding conductor provides a path for fault current to flow back to the source of power. Bonding ensures that all metal components are electrically connected, providing a low impedance path for fault current to flow between them. A low impedance fault current path is essential for electrical safety. It helps to ensure that overcurrent protection devices will operate properly and quickly, protecting against electrical hazards. Let's discuss the proper installation techniques for wiring in mobile homes. Proper installation techniques are crucial for ensuring the safety and reliability of electrical wiring in mobile homes. Firstly, always follow the NEC and local electrical codes. These codes provide detailed requirements for electrical installations, including wiring methods, materials, and grounding. Secondly, use the correct wiring methods and materials for the application. An M cable is suitable for dry, interior locations, while UFB or used cable is suitable for wet or damp locations. Thirdly, properly support and secure the wiring. Cables should be supported at intervals specified by the NEC to prevent sagging and physical damage. Fourthly, make all connections in approved electrical boxes. Electrical boxes protect connections from physical damage and provide a safe enclosure for splices and terminations. Fifthly, use the correct size conductors for the electrical load. The conductor should be sized to carry the maximum current that the circuit will be expected to carry. Sixthly, properly ground all metal components. Grounding provides a path for fault current to flow back to the source of power, helping to prevent electrical shock. Seventhly, test the installation after it is complete. Testing ensures that the wiring is properly installed and that all connections are tight. Eighthly, obtain an electrical permit and have the installation inspected by a qualified electrical inspector. An electrical permit ensures that the installation meets all applicable codes and standards. An inspection by a qualified electrical inspector helps to identify any potential safety hazards. Let's delve deeper into understanding ampacity and conductor sizing. Ampacity refers to the current carrying capacity of a conductor. It is the maximum amount of current, in amps, that a conductor can carry continuously under specific conditions without exceeding its temperature rating. Conductor sizing is the process of selecting the appropriate size of conductor for a particular electrical circuit based on the ampacity requirements of the circuit. The NEC provides tables that list the ampacity of various types of conductors based on their size, insulation type, and installation conditions. When sizing conductors, it is important to consider the following factors. Firstly, the ampacity of the conductor. The conductor must have an ampacity that is equal to or greater than the calculated load current of the circuit. Secondly, the temperature rating of the conductor. The conductor's temperature rating must be suitable for the environment in which it will be installed. Thirdly, the voltage drop in the circuit. The voltage drop in the circuit must be within acceptable limits, as specified by the NEC. Fourthly, the rerouting factors. Rerouting factors are used to reduce the ampacity of a conductor when it is installed in certain conditions, such as when it is bundled with other conductors or when it is exposed to high ambient temperatures. The NEC provides tables that list rerouting factors for various conditions. Conductor sizing is a critical aspect of electrical design. Properly sized conductors ensure the electrical system will operate safely and reliably. Undersized conductors can overheat, leading to insulation damage, fire hazards, and equipment failure. Oversized conductors can be more expensive than necessary, but they will provide a greater margin of safety. Proper overcurrent protection is essential for protecting electrical circuits and equipment from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. This helps to prevent overheating, insulation damage, and fire hazards. The NEC provides detailed requirements for overcurrent protection, including the types of overcurrent protection devices that are permitted, the sizing of overcurrent protection devices, and the location of overcurrent protection devices. When selecting an overcurrent protection device, it is important to consider the following factors. Firstly, the ampacity of the circuit. The overcurrent protection device should be sized to protect the circuit from overcurrent conditions, but it should not be so small that it trips unnecessarily. Secondly, the interrupting rating of the overcurrent protection device. The interrupting rating is the maximum amount of current that the overcurrent protection device can safely interrupt. The interrupting rating must be sufficient to handle the available fault current at the point of installation. Thirdly, the type of equipment being protected. Some types of equipment require special overcurrent protection devices, such as time delay fuses or motor circuit protectors. Overcurrent protection is a critical aspect of electrical safety. Properly sized and installed overcurrent protection devices can help to prevent electrical fires and protect equipment from damage. Let's consider the impact of environmental factors on electrical installations. Environmental factors, such as temperature, moisture, and corrosive substances, can have a significant impact on electrical installations. High temperatures can cause conductors to overheat, leading to insulation damage and reduced opacity. Moisture can cause corrosion of metal components, leading to electrical failures. Corrosive substances, such as salt spray or industrial chemicals, can also damage electrical equipment. The NEC provides requirements for protecting electrical installations from environmental factors. These requirements include the use of appropriate wiring methods and materials, the installation of equipment in suitable enclosures, and the application of protective coatings. In wet locations, the NEC requires the use of wiring methods that are specifically designed for wet environments, such as UFB cable or use cable. These cables have moisture-resistant insulation and jackets that protect the conductors from moisture damage. In corrosive environments, the NEC requires the use of equipment that is made of corrosion-resistant materials, such as stainless steel or fiberglass. The equipment should also be protected with a corrosion-resistant coating. Regular inspections and maintenance can help to identify and correct potential problems caused by environmental factors. This can help to prevent electrical failures and ensure the safety of the electrical installation. Consider the importance of proper documentation and record keeping for electrical installations. Proper documentation and record keeping are essential for maintaining the safety and reliability of electrical installations. Documentation should include detailed information about the electrical system, such as wiring diagrams, panel schedules, equipment specifications, and inspection reports. This information can be used to troubleshoot problems, perform maintenance, and make modifications to the electrical system. Records should be kept of all inspections, tests, and repairs that are performed in the electrical system. This information can be used to track the performance of the electrical system and identify potential problems. Proper documentation and record keeping can help to ensure that the electrical system is safe and reliable. It can also help to reduce the risk of electrical accidents and equipment failures. Consider the NEC requirements for working space around electrical equipment. The NEC specifies minimum working space requirements around electrical equipment to provide adequate access for maintenance and repairs. The working space must be clear of obstructions and must be of sufficient size to allow workers to safely perform their tasks. The depth of the working space depends on the voltage of the equipment and the presence of exposed live parts. The width of the working space must be at least 30 inches, or the width of the equipment, whichever is greater. The height of the working space must be at least 6 feet 6 inches, or the height of the equipment, whichever is greater. In addition to the working space requirements, the NEC also specifies requirements for illumination and access to electrical equipment. The working space must be adequately illuminated to allow workers to safely perform their tasks. Access to electrical equipment must be unobstructed and must be provided with a clear and safe path. Compliance with the NEC working space requirements is essential for ensuring the safety of electrical workers. Adequate working space provides a safe environment for workers to perform maintenance and repairs on electrical equipment. Think about the role of local amendments to the NEC. While the NEC provides a comprehensive set of standards for electrical installations, local jurisdictions often adopt amendments to the NEC to address specific local needs and conditions. These local amendments can vary widely from jurisdiction to jurisdiction. It is important to be aware of any local amendments to the NEC that are in effect in your area. Local amendments may address issues such as wiring methods, grounding requirements, and overcurrent protection. Local amendments are typically adopted by local electrical code enforcement agencies. These agencies are responsible for enforcing the electrical code and ensuring that electrical installations meet all applicable requirements. You can find information about local amendments to the NEC by contacting your local electrical code enforcement agency or by visiting their website. Compliance with local amendments to the NEC is essential for ensuring that electrical installations are safe and comply with all applicable requirements. Failure to comply with local amendments can result in fines, penalties, and even legal action. The presence of a skirt around a mobile home can provide some protection from moisture and physical damage, but it is not a guarantee that the under-chassis area will be considered a dry location. The effectiveness of the skirt depends on several factors, including the material of the skirt, the installation of the skirt, and the climate in which the mobile home is located. If the skirt is made of a waterproof material and is properly installed, it can help to prevent moisture from entering the under-chassis area. However, if the skirt is damaged or if it is not properly sealed, moisture can still enter the under-chassis area. In addition, even if the skirt is effective at preventing moisture from entering the under-chassis area, condensation can still form inside the area. Condensation can occur when warm, moist air comes into contact with cool surfaces. The amount of condensation that forms depends on the temperature and humidity levels inside the under-chassis area. If the under-chassis area is not properly ventilated, condensation can build up and create a damp or wet environment. Therefore, even with a skirt in place, it is important to inspect the under-chassis area regularly for signs of moisture. If moisture is present, it is important to take steps to eliminate the source of the moisture and to dry out the area. You should ensure proper ventilation to mitigate moisture build-up.